This is Unit 5A. It deals with satellite orbits and the uses of satellites generally. So beginning on the right here, we have a top-down view of the Earth. So we're looking at the North Pole is here, and the Earth is rotating beneath us. And we can see three orbits. So an orbit is a trajectory or a path around another body, a more massive body in space. Now the first thing to notice is that gravity is key here. The force due to gravity, or gravitational force, is pulling everything back towards the Earth. But we can see that as we get further away, it gets weaker. Now this obeys something called the inverse square law, which says if we get twice as far away, it gets 4 times as weak. But the fact that it gets weaker is the key thing to focus on. Now we can see that here. So with distance, this force, gravitational force, weakens, and it's there to create this circular path. So lots of things create circular path. The force can come from a piece of string on a small scale, but in this case, as I said, it's the gravitational force we're interested in. Now at a very low orbit, obviously this is not to scale. We've got 400 kilometers here, 36,000 kilometers, and all the way out to the moon here, but the idea is important. We have the International Space Station, which orbits once every 90 minutes, so very frequently gets to see almost all the Earth's surface, which is useful for satellites and spacecraft. Now out here we have a very special orbit in that its period of orbit is 24 hours. Now that's hugely useful because, as we can see, it exactly matches the rotation of the Earth. So this one happens to be above the USA. So if this was broadcasting TV signals, you wouldn't have to move your dish or track the satellite in any way. This is obviously very, very useful for lots of purposes, communication purposes. The downside is you only get to see a little bit of the Earth. So the ISS one here is more useful. More useful still, in a way, is a polar orbit. So now we're looking side on here, and we can see our polar satellite going around. Now this gets to see the whole of the Earth, because it's a bit difficult to visualize, but as it spins underneath it, in a certain period will, or in a very short time, will get to see every single bit of the Earth's surface. So very, very useful. Now the three we've mentioned so far have all been artificial satellites, so made by humans. The moon is also classified as a satellite, but it's clearly a natural one. It's been there for billions of years, but the physics is exactly the same. So gravitational force pulls it inwards, it has a tendency to carry on in a straight line, and this curvature balances out the two forces, or two tendencies I should say. More specifically then, we have a couple of uses here of satellites. We have scientific uses, so mapping gravity is obviously exaggerated here with the distance and the color, but gravity does vary, the strength of gravity varies. Military obviously uses them a great deal to track enemy movements. Weather is one we're very familiar with. Another scientific use here, the Northern Lights in particular. Environmental uses, so tracking growth and also burning of forests and the like. GPS is something we're also very familiar with, so it allows all kinds of navigation. Now the two central images give us a sense of just how busy or how useful satellites have become. It's a little bit of a doomsday image because it's obviously enlarged here, but it gives some sense of just how many satellites there are. Now this slightly bigger image here, we can see these far out ones here are the geostationary ones, the ones that are orbiting exactly in 24 hours. So they always, and you can see that they're strong. There's definitely a concentration at this distance because they are so useful. So there we have it, some key uses of satellites.